Hello dear students and learners. Topic of today's discussion is antibiotic resistance. Now, why there is need to learn antibiotic resistance? Or is it required? Yes, it is required because of inappropriate use of antibiotic that can lead to resistance, or you can say irrational use of antibiotic leading to failure of antibiotic therapy. Some of the antibiotics may cause allergic or hypersensitivity reaction, example penicillin, or ADR, you can say adverse reaction or toxicity, phototoxicity, microtoxicity due to antibiotic effects. And some of the antibiotics during treatment can alter microbiological or microbial flora, especially when antibiotics lying in a category of broad spectrum. So all these things or causes can lead to some of the changes in the bacteria, and that bacteria can show unresponse to drug effect, and that unresponse, it is lying in a big word. That word is drug resistance. Now, what is the definition of drug resistance? Drug resistance is unresponsiveness of microorganism to an antimicrobial agent after its immediate use. So two things are important why that resistance is coming. One is it's a sensitivity of response, and second is a repeated or antibiotics. In similar terms, tolerance is also used in relation to the human beings when there is need to increase the dose in order to produce pharmacological response of equal effect or duration. So what is antibiotic tolerance is? Antibiotic shows no longer killing effect of microorganism but inhibition of growth and multiplication, and it is particularly person's diminished response to a drug. And one more point you have to remember here, antibiotic tolerance is specially seen when there is a antibiotic therapy or antibiotic dose is stopped. That time microorganism starts growing up. But in case of resistant microorganisms, they show their multiplication, they show their growth in presence of antibiotics, and that is a difference in the two things, tolerance to resistance. And one more point to remember here, bacteria can increase their number or they double within half an hour and develop several generations of same bacteria in couple of hours, and that provides ample opportunity for them for genetic adaptation. And even resistance to chemotherapeutic agents develop to protozoa as well as malignant cells. Next, how resistance in a bacterial population can be explained. One of the point is individual to individual or person to person bacteria, from bacterium infectious bacterium to bacterium like plasmid. Plasmid is genetic structure or a small circular of DNA strand. It helps to transfer genetic material or gene. plasmid to plasmid by transposons or integrons. Transposons are especially chromosomal cells. Their transpositions bacteria. What are the examples to understand the deeply for resistance? One is penicillin resistant, Staphylococcus aureus, MRCA, penicillin resistant, Enterococcus, and third, multi-drug resistance, especially in the case of Mycobacterium tuberculosis scale, that is, drug is isoniazid. So in the case of tuberculosis combination therapy. So these are the some major example forwarded or kept on the slide. After resistance, how it spread, and through example learning. Some of the causes: overproduction of antibiotics, patient do not finish proper treatment or won't complete its therapy. Cost is one of the reason behind it, or feeling good after 2 days or 3 days therapy. Then overuse of antibiotics and poor infection control in healthcare settings, or poor hygiene or sanitation in individual lines. So some of the reasons are here, and these reasons can make therapy of antibiotics can enter into the failure, or complete eradication of microorganism by antibiotic won't see. And because of that, there is again required to deeply learn mechanism of resistance. One of the picture I shown on this slide, just go through that slide. See, on blue circular whole line between that structure number 1, we are seeing some blue bacteria and red bacteria. Red, which is carrying the resistance gene, which are smart, which are not showing any response to the antibiotic. Normally good bacteria or which are causing infectious or illness, they are killed or eradicated, and resistance carrying or smart bacteria which is transferred, and they grow in their favorable condition, they multiply it, and when they will come in a contact with another bacteria, they just transfer their genes or resistance factor to become more smart as that of previous one. So that is the bacterial transfer of drug resistance to another bacteria, and this will become more problematic to achieve highest effect of antibiotic, and that is the main reason for resistance. On this slide, you are seeing some of the components which are required for the antibiotics. One basic difference I told you, gram-positive. In case of gram-positive bacteria and gram-negative, that is the outer structure. Gram-positive cell wall. If it is a gram-negative, first cell membrane, and again there is cell. If you are using gram-negative antibiotic, that you are against antibiotic microorganisms like antibiotics. If you are giving this drug gram-positive, definitely as I said, half an hour. So not only this, the target differentiation, but also some of the channels or receptor bindings or enzymes or target also been modified, show their effects in a failure manner. So if it is a pump, there is a activation of efflux pump which is responsible in a drug excretion, that can make this failure. Second, if decrease uptake in changes of outer cellular permeability. Third, enzymatic inactivation is a case. Fourth, modification of the drug target. This antibiotic won't achieve its target, won't follow its proper excretion or achievement from its pumping mechanism, or uptake through the cell membrane, or alteration, or enzymatic inactivation. So these are some of the biochemical mechanism of drug-resistant antibiotics, especially chemotherapy. In this case, how we can overcome this? We prefer antibiotic with some antibiotic adjuvants or additional which are causing some problem or difficulty. That will be overcome by some additional component or fixed dose combination of amoxicillin nucleonic acid type of example, or beta-lactam inhibitor with flux pump inhibitors or permeabilizers. So combination therapy is utilized to achieve that strategy to unlock the increase in resistance. So this picture will make you clear about this antibiotic entry, that exists antibiotic, and if it's enter, how it's going to be failure or not to achieve this concentration. On next slide, you are seeing there is a major major points of RG in particularly acquired type of resistance. But here you just learn basically plasmid resistant gene when bacteria and bacteria pair together through that channel tube or structural components of the outer of the two bacteria allow that R genes to transfer. And in case of transduction, there is the help of virus or viral vector utilized for the transduction process. In case of transformation, bacteria is dead, R gene is transferred in the outer membrane, and that R gene or resistance gene is transferred in the bacteria, and it goes with the help of next cycle or multiply or that can cause the resistance to the antibiotic. So basically this resistance concerned with two things. One is the natural resistance, another one is acquired resistance. Natural resistance is also known as the intrinsic resistance. Mycobacterium tuberculosis always show resistance to some common antibiotics. Pseudomonas aeruginosa is naturally resistant to many antibiotics because of inability of antibiotics to cross its outer membrane or binds to its target tissue. And this type of resistance poses no significant clinical problem as only proper drugs are not to be selected. And here, remember, in a natural way, lack of transport system is seen and lack of target is seen. Therefore, it is especially concerned as a natural resistance. But in case of acquired resistance, irrational of antibiotics are the major consideration, and this resistance developed either by gene transfer or by mutation or by modification in the biochemical mechanism. In the last slide I showed that conjugation, transduction, transformation. So these are some methods which are carrying that R gene from bacteria to bacteria with the help of vector or from the outer environment. So it will achieve its R gene transfer mechanism and to get that resistance one to another bacteria. And this particularly acquired, there is a modification of existing genetic material. So remember this one, and acquisition of new genetic material from another sources. So three methods to be remembered here. Acquired, one is what? Gene transfer, another one is what? Mutation, and third one is modification in the biochemical process. Look at this slide, just read mutation, R gene, conjugation, transduction, and transformation. Okay, thank you. Next we will see next part of